back over here to my paper. Hello class, today we're going to have sort of a light day. We're going to be solving absolute value equations, and we're trying to remember what the heck is absolute value. I will try to show you. These vertical bars I'm drawing there denote what's called the absolute value, and I've written the absolute value of x is the distance between the number x and 0 on the number line. The fact that I'm using the word distance sort of lends us to think that it can never be negative. Distance cannot be negative. That does not make sense. Distance is never negative. Okay. For instance, if we had absolute value of 5. What's the distance? If you could picture the number line between 0 and 5 on that distance on the number line, that's easy, it's 5. There are 5 units between 0 and 5 on the number line. What about the absolute value of negative 5? No, don't say negative 5 as the answer. Suppose we have a negative number inside the absolute value bars. It's still 5. The distance between negative 5 and 0 on the number line is still 5. What I'm saying,
one is to the left and one is to the right, but it's still the same distance.
It doesn't matter if the number inside the absolute value is positive or negative. Once you take the absolute value, what word am I about to write over here on the right?
What sort of number will you get once you take the absolute value?
Positive. Mm-hmm.
Now 0 is neither positive nor negative. How far is 0 from 0 on the number line? It should be obvious. 0. So the absolute value of 0 is 0. The absolute value of any other real number is going to be a positive number.
Suppose here's an equation to solve. We've solved linear equations this semester. We've solved quadratic. Oh wow, we've solved a lot. We solved rational. Those are the ones with the fractions. And we solved the radical equations. Those are the ones with the square root of cube root. Here's what's called an absolute value equation. The vertical bars make it mean absolute value. The fact that there's an equal sign means it's an equation. Solve absolute value of x equals 9. Here's my thought process. I'm just thinking to myself, what are the only numbers that can be inside those absolute value bars? Give me a number I could put inside there that would have absolute value equal to 9. No, 9, okay. Positive 9. Is there another number? Negative 9. So what you've just done is solved your first absolute value equation. X has to be either positive 9 or negative 9. If we look at problem number 1, oh wow, look at that, only 7 problems here. So again, I know y'all went through a lot the last time. Let's see, is this one hard or easy? Absolute value of x equals, is that a 20?
Yes.
I'm trying to make sure that the absolute value bars look different from everything else. Maybe
from ones.
From ones, Okay.
What numbers can you take the absolute value of and get 20? There's only two of them.
Positive 20
or negative
negative
20.
20. We're doing the formal name in this assignment is called equals positive equals negative. And
They're
that's
solving absolute value equations.
that's my
that's
job. But you're going to remember it's going equal positive equal negative. When do you go equal positive equal negative? When there's absolute values in it. It's sort of important to be able to distinguish what we're doing today from what we did on Monday.
Remember, they didn't used to have the plus minus key. Back then, you'd had to type 20, comma, negative 20. That's why they say use a comma if necessary, but we can just do plus minus 20. Any questions there? Now, Tony, what were you saying?
Well,
You were saying something, but I just wanted to type that in.
Good. Let's look at number 2. It says absolute value.
Uh-oh, this isn't good.
Absolute value, solve this equation of x equals negative 44. Well, I guess you may have noticed on question 1, the way you have the two options. Did they see the options on there? Show it, John. You see, we have that no solution, empty set option there. When does that happen? Well, here's a common wrong answer. Go back to number 2. What do y'all think the wrong answer is? People will say x equal plus minus 4. No. No, no, no.
No matter what's inside those absolute value bars, when you take the absolute value, what sort of a number are you going to get? Positive. So are you ever going to be able to have an absolute value equaling negative 4?
No. This is going to be an empty set or no solution, however it's worded on the, how do you spot the no solution ones? The number that's not inside the absolute value bars should not be negative.
But that's only that's true only if this absolute value is isolated. If you have other stuff over here outside those absolute value bars, you may have a negative number there. You need to make sure that your absolute value expression is isolated before you decide no solution. If it's not isolated, then go ahead. I'll be quiet.
Now, there are 3 general cases for absolute value equations. The first type have absolute value equal a positive number. If that's the case, then there'll be 2 solutions. The problem number 1 is an example of that. Absolute value equals positive 20, so x is plus or minus 20. So you have absolute value equal positive, 2 solutions. There's one case where there's only 1 solution. If you have absolute value equals 0. What's the only number that I could put inside here to have absolute value equal to 0? Just 0. There's only 1 solution then. Can y'all guess what I'm about to write? I have absolute value equals positive. I'm about to write absolute value equals negative. How's it showing? Let me move this up a little. And what did problem number 2 tell us about absolute value equals negative? No solution. But in order
to number these cases, letter them A, B, C.
Oh, okay.
Yeah.
Oh, wow. A, B. What were we looking at the other day where there was all this, they were numbering 1, 2, and then they had A's and B's, and number 2 was just blank, and number 1 had an A but no B. I don't remember. Maybe the rules have changed, but
For
remember,
making outlines.
yeah. You could have a 1 without a 2. You could have a A without a B. Maybe they don't. Maybe that's no longer the case. But now I'm doing like someone else I know and just rambling.
I want it noted though, Tony. I was the one that kept us going. Oh, by the way, on number 2, what am I about to check? Absolute
Oh,
value of
yeah.
x equals -4. There's no solution.
Okay.
Now this one.
Well, before we do that, I want to go ahead and make a note of something you've already told them. Here's an important rule. If you're going to decide how many solutions you have, you've got to make sure that the problem's written the way it is right here in these cases. Always, always, always. I'm going to put a little cube there because that means always, always, always. Isolate.
Oh wait, I did switch you.
Oh, the absolute value bars first. It's a very important statement.
When we start solving absolute value inequalities on Monday, that's still going to apply. You need to isolate the absolute value expression on one side before you do anything else.
Mm-hmm. And I'm going to make up a little example. EX. Here it is. The absolute value of x plus 7 equals 3. If I'm wondering, well, what kind of equation is this? Are there going to be 2 answers, 1 answer, or no solution? Before I can decide that, those absolute value bars must be isolated. Or on this example I have right here, are the absolute value bars by themselves, or is there a little 7 over there with them? You've got to get this absolute value bars by themselves, which means what would I need to do to both sides to move this 7 to the other side?
I heard subtract. I agree.
I thought I'd said something wrong. So we have the absolute value. Once I do this, absolute value equals -4.
What do you conclude there?
I'm going to give them a choice. Is
Two
my
solutions.
answer going to be ±4 or no solution?
No solution.
No solution. So can you just look at it and tell no solution? No, not unless the absolute values bars are isolated. So no solution. So I think I've told you everything you need to know to do all of these problems. Let's start with number 3. Now we'll just go straight through. Absolute value of x minus 5 equals
27.
27. On this one, are the absolute value bars isolated?
Well, the step inside them is messier, but I still claim the absolute value bars are isolated already.
Yeah, the 2 bars are on the left side. Hey, we have a positive number on the right, so is this going to be a no solution?
No.
No. So here's my thought process. I'm ignoring for a moment that x minus 5, and I'm just thinking to myself, what are the only 2 numbers that can be inside those bars? What are the only 2 numbers that have absolute value equal to 27? I'll get us
Write
started.
them above it. Write it
Positive
above what
27 and,
write it right up there. Write them up there.
huh?
So you said it can be pot 27
27 and
Or-
what else? Negative 27. We're going to have 2 equations here. And again, this is called, this technique we're doing is equal positive, equal negative. If there's something other than just x inside the absolute value bars, just take what's inside there, set it equal to positive 27, set it equal to negative 27. And then solve those two equations. Are y'all following my logic? The only two numbers that can be inside those bars are 27 or negative 27. So let's figure out what x value would give us a 27. How do I solve the first equation here? And it looks like I have a 2.7 there, doesn't it? Okay. Again, no
There are no
decimals.
decimals in this lesson
I
either.
just touched my pen down. So, what would y'all do to get this x by itself?
Plus 5.
Okay, add 5. So we have x equals 27 plus 5. Is that going to be a 32? And this one you can sort of check in your head pretty easily. 32 minus 5 is 27. And the absolute value of positive 27 is 27. Now don't say negative 32. Okay, that might be tempting to do, but don't. Over here, when I do the same thing, I'm not going to get negative 32. What am I going to get? X equals negative 22. Adding 5 to both sides. So negative 22 minus 5 would give us negative 27. And the absolute value of negative 27 is 27. So 32 and negative 22.
So 32, comma, negative 22. Any questions there? Okay, let's get a little messier.
Number 4. Okay, so that's not a 14. You see, I want to write it so it doesn't look like 14x minus 31 equals 6. So I'll use big, black, bold absolute value bars.
Yes.
Sorry, so on that last problem, I know
Go
it was
back.
32 and negative 22 for the solution set. So if the problem was x minus 5 equals negative 27, that would be no
solution.
Okay.
That's correct.
Oh, so wait, so if it said absolute value equals negative 27,
If the absolute
that
value
would
of
have been no
x minus
solution.
5 equals a negative 27, no solution.
Any other questions?
Is this going to be a no solution? No, because we already have the absolute values isolated on one side. Nothing's being added or subtracted or anything to that absolute value. So the absolute value is by itself. We have an absolute value equals positive. How many solutions do we expect to have here? We expect to have 2. That stuff inside those absolute value bars, in order to equal 6, the stuff inside there has to be positive or negative 6.
Y'all hear that? The only two numbers that have absolute value equal to 6 are positive 6 or negative 6. So we'll take what's inside here and set it equal to positive 6. Then we'll set it equal to negative 6. Or if you want to go equals negative 6 first, the order doesn't matter. I always just, my habit is equal positive, then equal negative. So I'm now going to isolate this x. I would do what?
Plus 3.
Okay, add 3. The 6 plus 3 is that a 9? And then what? Divide by 4, yeah. So it looks like 9 over 4 is the first answer I found. Over here, let's see, on the purple one, I will add 3. So we have 4x equals negative 6 plus 3. Is that going to be a negative 3?
Yes.
And then divide by 4. So negative 3 over 4. So if I plug a positive 9 over 4 in, the 4's would cross cancel and we just have 9 minus 3, which would give me positive 6. If I plug the negative 3 over 4 in, the 4's would cross cancel And negative 3 minus 3, that's a negative 6. So positive 9 over 4 gives us a positive 6. Negative 3 over 4 gives us a negative 6. Oh, you.
I'm just going to switch.
Oh, okay.
9 over 4. Get out of the denominator before you type your comma, and then negative 3 over 4. Is that it? Any questions there?
Well, it's going to have to get harder because we're already up to number 5 and there's only 7 problems. Absolute value of 3x minus 6 equals 6. Okay, so I'll put my...
While he's writing that down, there's only one correct first step. Be thinking about what that step is.
Absolute value of 3x, then minus 6 equals 6.
Okay, what's the correct first step? And you gotta isolate that absolute value
Like
first,
my
okay?
little red
You gotta
star.
isolate the absolute value bars before you decide which of the 3 cases you have. So,
Isolate the absolute value bars first, and I heard add 6. Is that what I heard? So I'm just going to move the 6 over. If you want to write plus 6. So we have absolute value of 3x equals...
what have we got on the right side?
12.
12, I agree.
So this is one of those things that the logic of why we're doing equal positive, equal negative, you should understand that. There are some things, okay, I don't know why that negative b plus minus square root b squared minus 4ac all over 2a works. Well, it works because we said it did, okay?
It's very easy to
it's
derive once we complete
Once we complete the square, if we have time that day, we'll go through and derive that quadratic formula for you. But on this one, it's not like that. You should understand why. We're saying, what are the only 2 numbers that have absolute value equal to 12? Well, 12 or negative 12. They're the only 2 numbers that can be in here. So the logic is either 3x equals 12 or 3x is negative 12. It's hard or easy to solve for x here.
What's he going to do to get x by itself?
Divide the 3.
Divide by 3.
So not too hard. We get x equals 4. And what's the other one?
Divide by 3.
And we're going to get x
Negative 4.
equals negative 4. Yeah. So don't always expect the same number in your answer, like the number 4. 9 over 4 and negative 3 over 4. Positive 32, negative 22.
If you have addition or subtraction inside the absolute value bars, you're definitely not going to have the same number just with opposite signs. Here there was no plus or minus inside the absolute value bars. So yeah, you wind up with the same number, just opposite signs. But that doesn't always happen, as we've seen. How do y'all want me to type it? Y'all want me to type 4 comma negative 4, or I think I'll use the plus minus key. I'm feeling lazy after that class on Monday.
You deserve to use the plus minus
I
key
do.
and have an easy day.
Okay,
But we could type it in either way.
You could
type
say
it
4
either
comma
way.
negative 4. Oh wow, it's got to get harder, doesn't it? They've got to bring in some fractions. Absolute value of, let's see, 2x minus 5 all over 9 equals 5. Look, there's a lot of stuff inside the absolute value bars, but hopefully you agree with me that the absolute value bars are isolated. Doesn't matter what's inside them, but those bars need to be by themselves, and they are. Okay? So, hey, if we ever notice after class something left in here, uh, we sort of loiter around in here for a while, uploading the video, getting the room back. But let's suppose you get home and realize, oh, I had my phone plugged in charging and I left it there. How you can get all the way home without noticing your phone's missing, I don't know. But if that happens, and we see it,
We'll bring it downstairs to the
main-
math office,
yeah,
to
the
the
main
main
math-
math office.
downstairs, it's a shame. I don't know what room number that is.
I don't
But it's in
either.
that middle part of this building where all the offices are. There's the the math chair, the English chair, all of them are down there.
Mhm.
In that part of the office that's not connected to the part that has an elevator. Does that make sense?
Right.
This weird shaped building. But okay, have I talked long enough? Don't let the fact that there's a fraction bother you. There's a positive number on the right. The absolute values are by themselves. So that means that we have
How many cases? Two.
two.
That stuff on the inside has to equal positive 5, then the stuff on the inside has to equal negative 5.
So don't let the fact that it looks bad go. Equal positive and equal negative. Are you wondering, well, why didn't we go equal positive and equal negative on Monday? When do you go equal positive, equal negative? When you have absolute value bars. It's sort of important to be able to tell to distinguish the differences here. So you go equal positive, equal negative when you have the absolute value bars by themselves and there's a positive number. By the way, I'm pointing to this green 5, just FYI, if it had been a negative 5, what would the answer have been?
No solution.
No solution. Those are the easy ones. So let's see. I think I'll multiply both sides here by 9.
Hey, Tony, do you remember the little cross multiplication?
Yeah, I could
You
do
could
that
do it
too.
like that. Do y'all remember cross multiplying on Monday?
Fraction equals fraction. I'd do it like this. We'd have 2x minus 5.
What's he going to have on the other side?
What number will be on the right?
45. 5
Good.
times 9 is 45.
So let's see. How do I go about solving this for x? What am I going to do first? Add that 5.
Add 5,
Good.
I agree.
So we have 2x equals 50.
And then
Divide by 2.
divide by 2 to give us x equals.
25.
So there's my first solution, 25.
Let's do the same thing on the left. Don't expect the answer to be negative 25. It might be, but probably not. Let's see, what color am I using? Blue. So 2x minus 5 times 1 is just 2x minus 5 equals negative 45. Oh, I like this problem. The answers aren't going to be fractions. Now, what do I do here? Well, same thing I did over there. Add 5 to both sides.
So we're going to have 2x equals what? Negative 40, okay. Negative 45 plus 5 gives us a negative 40, and then
Divide by 2, that's right. And we get x equals
Negative 20.
negative 20. Good. So positive 25 and negative 20 are my two answers. If I plug a positive 25 in here, I get a positive 5 in there. If I plug a negative 5 in here, I get a negative No, if I plug a negative 20 in here, I get a negative 5 inside there. So positive 25 and negative 20.
Any questions?
And we want to
Let's go and
Type
realize
that
the
in.
order doesn't matter at this point. I can type in I'm just typing them in the order in which I get them. But on Monday, when we go to interval notation, you will have to be putting those numbers in numerical order. We'll discuss that more
Yeah. In case
at the end of class. Hey, we
Yeah.
can do some interval notation at the end of
that's what I was
class,
going to do.
because this is the last assignment problem.
Last problem. But we'll still have a little bit more to do just to get y'all ready
So
for
don't start
Monday.
packing up as soon as this is over, okay?
Yeah. We'll probably pack up closer to 3, but that's it.
Mm-hmm. The
Now,
absolute
that's
value
not a
of m
1m
plus 3
plus 31. That's a m plus 3.
inside the absolute value bars, and then a plus 2 equals 6.
There's only one correct first step.
-2.
Okay, minus the 2. You've got to isolate those absolute value bars first. Always, always, always isolate those absolute value bars. So we have absolute value of m plus 3 equals, what's the number going to be on the right?
4.
4. And of course, it couldn't have turned out to be a negative 4, because then we could have said no solution, stopped. But that's not hard. After everything y'all went through the last time, this will be a piece of cake.
Is it no? Oh, we've already said it's not no solution. How many cases are we going to have here?
2.
2. M plus 3 has to equal.
What 2 equations am I going to write?
+4.
4.
Positive 4 or
-4.
negative 4. Everyone's so quiet today. I think I really scared them with those rational and radical equations the last time. It's like I've broken their spirits, and I didn't want to do that.
Oh.
Damage has been done.
Oh, I'm sorry about that.
Maybe we should move and just start logarithms on Monday instead
Yeah.
to lift their spirits up. And you think I'm joking, but students always do well on logarithms. 4 minus 3 is 1. So there's one of my answers.
Y'all tell me what the other solution's going to be.
I'll get you started. M equals,
-2.
good, did y'all hear that? -7. Move that 3 over by subtracting. So a +1 and a -7.
And if you'd done this with plus minus 6, I don't know what you'd get, but I'll tell you one thing. One of your answers would be correct if you did a plus minus 6. I think this one would be right, but this one would be wrong, and my lab would count it all wrong, okay?
And I'm glad you mentioned that, because if you notice you're getting one number right and one number wrong,
Then you're not isolating the
first.
absolute
If
value.
you started off with m plus 2, 3 plus 2 equals +6, and m plus 3 plus 2 equals -6, you're going to get one right answer and one wrong answer. Oh, wow. I think that's the fastest 100 we've ever gotten on a homework assignment.
Yeah.
But here's another problem.
Here's
I have
another.
one for
This is going to pop up on Monday with inequalities.
It's going to be the hard part of number 11 that we do on Monday.
Okay.
Absolute value of x squared. Oh, it's quadratic. I said x squared plus 4x minus 25 equals 20. Okay.
Do we have to move terms around, or is the absolute value already isolated?
Already.
It's
Yeah.
already isolated. Well, we have that messy step on the inside, but the absolute value itself is already isolated.
So, what are the only two numbers have absolute value equal to 20? What are the only two numbers that can, oh, why am I doing that? That can go in there. Either, I'll get you started. It's either got to be a positive 20 or what?
Negative.
A negative 20. Positive 20 or negative 20. So our two equations, they're going to be quadratic equations. We have x squared plus 4x minus 25 equals positive 20, and x squared plus 4x minus 25 equals negative 20. It's the same logic that we were using on the previous problems. The only difference now is that x squared. These are quadratic equations. We've been solving quadratic equations using two primary methods, either factor or use the quadratic formula.
Either way, you need what number on one side?
Zero.
Zero. For this first one, where do you think we'll get the zero? The left side or the right side?
Right.
Remember, I don't want to move the term, the x squared term, if it's going to make it have a negative coefficient. So
we have the equation x squared plus 4x. What's that going to be? Negative 25 and then a minus 20. Is that a minus?
45.
Ooh, 45. I heard 45 and wrote 40. Oh, shoot. Now I'm doing something like you, Tim. I'm making a big mess. Oh, and whenever you mess up and you just start writing over it, that only makes it worse.
You see, I'd mark out that whole line and rewrite
Okay,
it.
you're
Tom.
right. X squared plus 4x minus 45 equals 0. So now we're going to solve this by either factoring or the quadratic formula. I'm going to use factoring because what do we call those trinomials where there's not a number, just a 1 in front of the x squared? They're easy to factor. What are they called? Another word for easy starts with S.
Simple trinomial.
Trinomials. So because it's going to be x and x. Let's see, the last sign is minus, so it's going to be a plus and a minus. So, numbers that multiply together to give 45. X and x. Last sign minus, so plus and minus. Oh, there's quite a few little pairs that multiply together to give 45. Here's my scratch word. 1 times 45. 3 times 15. What am I missing?
There's another one.
Part of the multiplication table. 5 and 9.
For a simple trinomial, you choose the pair that subtracts to give you 4. That last sign, I had a question from an online student about this. How do you know whether they're supposed to add or subtract? For a simple trinomial, you choose the pair. That last sign says the pair has to subtract to give you that middle number there, 4. So which pair will we use?
See, like my little table from way back on January 27th, 2025. The second sign is minus. Those signs the outer inner have to subtract.
Okay.
Okay, so which pair did y'all say we got to use?
And while we're thinking about signs, which pair did you say we're using? It should be obvious.
5 and 9.
5 and 9, because 9 minus 5 is 4. But where should we put the plus? Remember, we want a positive 4x. Is the plus going to go in front of the 5, or will it go in front of the 9? In front of the 9, I agree.
Now, we factored it. So set each factor to 0. x minus 5 is 0, or x plus 9 is 0. We're going to get two green answers here.
It looks black to me, Tony.
Well, yeah. But on the video, so usually the colors show.
Colors show better on the video.
Okay, so it's going to be a positive 5 and what else? Negative 9, okay. Now we'll do the exact same thing over here.
We need to get 0 on one side, so we'll add that 20. That's going to give us x squared plus 4x, and what else are we going to have there? Okay, I agree.
Now, let's,
Two sets of parentheses. Yeah. Oh, this is pretty. This is nicer than the first one.
Is this another simple trinomial?
Mm-hmm.
Yeah. X and x.
What's the only pair of positive integers that you can multiply together to give you 5? 1 times 5, and sure enough, if you subtract 5 minus 1 gives us the 4 that we need.
Mm-hmm. And since that last sign is negative, we need a plus and a minus. How do I arrange it? Where does the plus go? On the
plus 5.
Good.
And then minus 1 gives us a positive 4x. A bigger number gets that positive sign because we need that first sign there to be plus when you combine the outer and the inner. And then
setting each one of these to 0. We're going to get 2 more answers. We have what's this one going to be? X equals 1. Good. And x equals?
-5.
-5. So it's a little bit more involved only because we got to factor it, but it's still the same logic. Okay. Now,
I'll do this interval notation now.
Okay.
I can't type the answer in because we just made up the.
Oh, I know.
You just made up. But why don't you box those answers just so it says, let's pop psychology. It says you finished an unpleasant task and you're ready to move on.
Notice how there's 4 answers there. So really, in my little generalization, when I said equal positive has 2 solutions.
2 cases.
2 cases. Well,
there are 2
there's
cases.
only 2 numbers that could be inside there. 20 or -20. Has 4 answers, but okay. Now, Tim, so you want to review something that we've got to know well for the next class meeting? It's not hard. Something called interval notation. Oh, I thought you wanted to use mine.
No, I have my own.
Oh, okay.
Yeah. Okay, let's review interval notation, just because you're going to be using that on Monday. Interval notation is used to represent intervals on a number line. How about shaded regions on a number line? Shaded intervals on a number line. But you're using the word interval. I'm trying to avoid intervals on a number line. When I use the word region, to me that says a 2-dimensional space. I don't think this is so. Just a one division on a number line. Now, if you took Math 371 recently, you might recall seeing interval notation. If not, it's painless enough. I'm going to draw out a number line. And remember, on the number line, it goes small to big. So when you're labeling numbers on a number line, the numbers have to go from small numbers to big numbers. Like I'll say there's -8. And 5 and 1. No, that should be a -5. negative 5, 1 and 7. And I think I'll have, oh, I'm going to do several of them. So
okay.
I think I'll start off there. Let's suppose that at this negative 8, we have it labeled with a closed dot. That says we're including negative 8. Negative 8 is going to be part of the interval, but let's use an open dot at negative 5. That's saying that something like negative 4.9 is going to be in the interval, but not negative 5. And I think I'm just going to alternate. Closed, open, closed, open. As we go through the class on Monday, what we're going to do is we're going to have to start off. We're going to go through this process to come up with these numbers. These numbers that are labeled on the number line, we'll refer to them as cut points because they're cutting up the number line, okay? Some of the intervals are going to be shaded, okay? Some intervals will be shaded and some will be crossed out. For this case, I'm just going to assume an alternating pattern. The first interval is shaded, the second one's crossed out, the third one is shaded, the next one is crossed out, and let's say this one right here is shaded. So that's saying something like 5. 5 is right here between 1 and 7. 5 is in the interval that's crossed out, so 5 wouldn't satisfy the inequality. The only numbers that satisfy the inequality, that make it into a true statement, are in the shaded intervals. Something like 0. Here's 0. Would 0 satisfy the inequality? Yes, because it's in the shaded interval. Here's what you do. You have to go left to right, small to big. You look at this first interval and you ask yourself, what is the leftmost endpoint? Well, there isn't one. This interval keeps going and going forever to the left. So I'm going to denote that with a negative infinity. My left-hand endpoint is a negative infinity. To express this little first interval with interval notation, you always use a parenthesis in front of a negative infinity. So parenthesis, negative infinity, comma. The right-hand endpoint is a negative 8. To indicate that the negative 8 is closed, that means you're including negative 8. You get there and stop. We're going to put a rectangular bracket after it. So every number to the left of negative 8, including negative 8, is in our solution. Well, what about these numbers here? I'm going to say or, and this little symbol there, that's a union symbol, and it'll be found in the toolbar. That's sets the symbolic representation of the word or. So I'll say toolbar. You'll find that in the toolbar on Monday when we start typing in these answers. We start here. The left-hand endpoint is negative 5, but it's not shaded. If it's not, the only time you use a rectangular bracket is if the endpoint is shaded. It is not shaded, so we put another parenthesis. Negative 5, comma. The right-hand endpoint is a 1. It's shaded, so we have another rectangular bracket. This little interval here is saying every number between negative 5 and positive 1 on the number line. It includes 1, but it doesn't include negative 5.
So it's a shorthand notation, what you're saying.
Yes.
Okay.
Or we have one other shaded interval. The left-hand endpoint is another open circle. Open circles always represented by parenthesis. You start at a 7. The left-hand endpoint is a 7. I don't see a right-hand endpoint. What's our right-hand endpoint? An infinity, that's a positive infinity. You always put a parenthesis after a positive infinity. You always put a parenthesis before a negative infinity.
Do you want to tell them where the infinity symbol will be? It's on
A
the toolbar.
toolbar. There is an infinity symbol on the toolbar when you're typing this stuff in. I'll get emails from my online students. Oh, there's no negative infinity symbol. That's right. Just like there's no -7 on a keyboard. You have to type the negative from the keyboard and then the 7. Likewise, you'll have to type the negative from your keyboard and then the infinity symbol. But
Always
here's my...
It only has positive infinities. So what you've written there is a shorthand way of saying every number to the left of -8, put a negative in front of the 8,
Oh, yeah.
including -8. Every number between -5 and +1, not including -5, but including 1. And every number to the right of 7, not including 7. It doesn't make sense to talk about including infinity. That would be as stupid as saying including the arrow at the end of a number line. That's why you always put parentheses. Now, if I can, I want to come over here, get out of that, and, oh wait, let me do it again. The next time on Monday, we're going to have this little recipe. I call it a recipe.
It's stored under files on Canvas. If you're not here on Monday, that's where you find this recipe for the cut point method.
If the printer's working in the office thing, I'll print some office, in the math department suite. I'd like to have some printed out for Monday. So if you're here, I'll give you a paper copy if the printer's working. If it isn't, well, we're just going to have to deal with digital copies. But there's this little sequence of steps. I remember years ago a teacher telling me that had never seen this thing, saying that cut point method will solve anything,
any inequality
that has a less than or greater than symbol. That's what an inequality is. And they said, I don't understand why it works, but it sure does. I remember,
I was like, oh wow, you have
wow.
a PhD in math and you don't understand why this works.
Oh wow.
That bothered me.
That bothered me too. But
we're not through. I want to do one more number
I wanted to mention, if you're trying to think, I need to summarize what he just said. Here's
look at step number 5.
If you follow this recipe correctly, you're going to be drawing a number line and labeling these cut points, and
some of the intervals will be shaded and some will be crossed out.
And there'll be some open and closed circles. This little recipe, it'll walk you through. You don't have to understand why it works, but it sure works, I guarantee you. And it might be a little different from view and example, if you're a view and example kind of guy. But once you're through with step 4, you now have a number line shaded with cut points and stuff. Let them see the number line. And you then take it and write it in interval notation, summarizing what he said. Step 5. Let me make this bigger so I can read step 5.
Use a square bracket for closed circles. That's what we did on our number line. We used a parenthesis for open circles. We always use parentheses for infinities or negative infinities. I guess I could have said you use a square bracket for closed circles and a parenthesis for everything else.
Yeah, that would be a good way of working. Yeah.
One more.
Okay.
Mm-hmm.
So I'm going to draw a number line, put some cut points on it.
Oh, let's see. I'll say a -4 and a -2 and a 3 and a 5 and a 9.
Hey, if I ask you, where does this number line's been broken into 1, 2, 3, 4, 5, 6 regions. Where would 0 be in this number line?
Yeah.
Between -2 and +3.
So it's
That's
here.
going to be important.
Zero will always be between negative and positive. Like over here, where was zero? Right there.
-5 and 1.
Between the -5 and the 1.
+1.
By the end of
Okay.
class on Friday, you'll be able to, Monday, you'll be able to find zero on a number line. And that's a joke. You should be able to find zero on a number line before.
That joke did not go over
It
well.
didn't. So with those 5 steps, the first 3 steps are telling you how to find those cut points and how to put them as open or closed circles. Then
And
step
let's
4 tells you how to
suppose,
shade it.
let's suppose, I think I'm going to shade. Okay, let's cross out the first interval, shade the second interval, cross out the third interval, shade the fourth interval, cross out the interval from 5 to 9, and shade the interval afterwards.
This is not a bad way to end the 4th week of the semester.
Realize that this side of the number line is negative infinity, but it's crossed out, so we're not going to be writing that interval. You only express the intervals that are shaded. Here's the positive infinity. The intervals that are crossed out, we just ignore. What's the left-hand endpoint of this first shaded interval? -4, what will go in front of a -4? I couldn't hear you. I'll give you a hint. It's either a bracket or a parenthesis. No, let's look back at the little step. For a square bracket, you use closed.
For closed circles, you use a square bracket.
So it's closed. We'll use a square bracket. You must type a comma then before you type the right-hand endpoint. What's the right-hand endpoint? -2.
Now, Tim, would it have been okay if I'd listed -2 first and then comma -4?
You must go from small to big. You cannot have -2 followed by -4. The endpoints have to go in numerical order. The smallest one is -4. The next one is -2. It's not shaded, so what are we going to put after that -2? Okay, parentheses. Or so there's my union symbol that I got from the toolbar. Call out this next interval as if you were typing it in. What would be the first thing you'd have to type? Now for the parentheses and the bracket, you'll have to be using the keyboard, okay? So there's the bracket, and then I have the left-hand endpoint is 3, comma, 5. What's going to go after that 5? I should be calling these numbers cut points because that's what we're going to be calling them on Monday, the way they cut up the number line. What's going after 5? Parentheses because it's not shaded. Or now the last interval. Call it out as if you were typing it in. What's the first thing that I need here?
Bracket.
I need a bracket because 9 is shaded. I have the interval 9. What do I have to type next? You have to put that comma and then the right-hand endpoint. It never stops, so to indicate that, we put our infinity. And what always goes after a positive infinity? A parenthesis. You only use rectangular brackets at closed circles. You only use closed circles at solution cut points,
which we haven't gotten into,
and which the inequality involves equality. We'll be discussing all of that on Monday, so you have something to look forward to. We've been solving equations on Monday instead of having an equal sign in the problem. Suppose you have a less than, greater than, less than or equal to, or greater than or equal to. That's what we're seeing on Monday.
Yeah.
Any questions there? And stop recording, Tony.
Oh, okay.
Yeah.
Well,
Since you're not even showing for that written there, then you may as well stop